And for the binomial distribution regarding to the mean and the variance and standard deviation, right? For usual probability distribution, the mean will be the sum of x times the probability. Right, the variance will be sum of x squared times probability minus the square of mean, and the standard deviation will be the square root of the variance. Right, that's for every probability distribution. It is true. Right, binomial distribution, or to find the probability itself, is very hard already using the parameter n and p. Even though we get the table, right? Even though we get the table, if n is like 12, then even for p is 0.4 to get the entire value or entire mean or standard deviation or variance, that will be very hard. So therefore, for binomial distribution, to find out the mean, variance, and standard deviation, we have special formula. Right? It was developed from the original formulas, but the result is pretty simple. The expected value or the mean of the random variable will be the parameters product, or the product of two parameters, n and p. N times p will be the mean. Well, such like you getting the newborns of, like we had an example before, right? 14 newborn babies, equally likely assumption is the assumption. Then our likelihood to get the boys, or not our likelihood, our expected number of getting a boy or expected number of girls is just 14 times 0.7. I mean 14 times 0.5, assuming equally likely, which is 7. Right? The 7 is the expected number of getting the girl or expected number of getting the boy, same thing. Right? Which is the product of n and p. And the second question we have seen, if the probability of getting a girl is getting lower, then our expected number of getting the girl in that question was 14 times 0.48 is a little lower, right? 14 times 0.48, that is 6.72. Well, again, that's expected number. In real, we're not getting partial of kids, but that's what it is, right? 6.7. It is a little lower in the distribution. And the variance is n times p times 1 minus p. And of course, the standard deviation is always the variance. Well, in this case, it's the square root of np 1 minus p. Right, but that is a relatively simpler formula than what we had before for the usual distribution. Well, for usual distribution, we need to do a lot of times, especially for the binomial distribution. It's very hard to get the table. Even though we can get the table of the likelihood, then it is also still very hard to do the product and do the summation. Right? The simpler formula or shorter version is that. Well, the proof from this to that will be a little too much for our course, and yeah, that will be a little too much for this course here. But that's some bridge between this to here. We use the probability of x, which was the long probability formula. Then we could illustrate it step by step and to get final result to be n times p. Right. Anyhow, that is the formula. The mean, variance, and standard deviation for our binomial distribution has n trials and probability of success for each trial is p. That is it. And we can see some example regarding that. Right. Well, there was an assumption that 40% of the population in the US have brown eyes. And well, now here is 14 people are randomly selected or selected randomly. Is it unusually high to get 12 brown eye people? Right, so asking, well, is it unusual? The first method we can use is the probability method. Right, for the probability method, if the probability is smaller than 5%, then we say it's unusual, right? If more than 5% or more, then we can say it is usual. It's not unusual. And how we see an event is unusually high, we find the probability of this number and the more extreme, right? Which means higher. So this one, x is the binomial distribution. Right, follows the binomial distribution, which 14 are selected and 40% to have brown eyes, and we have 12 brown eye to asking for unusually or no, unusually high or no. 14 and 40%. A binomial distribution for n to be 14 and p to be 40%, which is 0.4. Well, asking for is 12 extremely or unusually high. We were looking for a value of 12 or more for the probability, right? Certain value and more extreme. Here asking for is that unusually high, so we go 12 and higher. $12 and higher for a total of 14, that means it is 12 or it is 13 or it is 14. Then we could go to the table, right, of n to be 14, that block, x value, and the p to be 0.4, right? The column need to be 0.4, and the x values are 12, 13, and 14. So the block of 14, block of 14, and column of 0.4 as the p-value, and we need to go to the rows of 12, 13, and 14. Right, the table here is only 4 digits of decimal. When we see some value like 0.0000, it doesn't mean it is 0, it just means the probability is very, very small. Right? It couldn't be exactly 0. If you try the formula and calculator, you'll find out something, and the number maybe have more digits of zeros before the first significant figure. Right? And here was 0.0000 means maybe the fifth one is smaller than 5, or maybe the rest are also zeros until the first significant figure. But that's what we have. Right, so just copy from the table. For 12, that's 0.0005, 0.0001 is for x to be 13, 0.0000 for to be x to be 14. Right, that is from rounding. It doesn't mean it is 0, it's just from rounding. Then we get the value is 0.0006. Right, I have the value. Then from the probability method, we can see the probability of 12 or more is less than 0.05. Therefore, 12 is unusually high. That is use the probability method. We can see the likelihood is very, very low. That means 12 is unusually high. Right. That is the A method. Use the probability. I use the range rule of thumb. The range rule of thumb means, well, the usual range is within 2 standard deviations of the mean. Out of that range, well, the values are unusual, right? So within 2 standard deviation of the mean. So we need to find the mean, we need to find the standard deviation, and 2 standard deviation less, 2 standard deviation more to the mean will be the cutting value for the range. Then out of that we can see if 12 is out of that range. If it is, then it's unusual. If it is not, then it's not unusual. Right, we have seen in part A already, it is unusual. So our part B answer should agree with whatever we have found. So again, X itself is a binomial distribution. 14 trials. Probability of getting the brown eye is 40% for each trial. Therefore, we can find the mean, we can find the standard deviation. For the mean, that's n times p, which is 14 times 0.4. Right, the mean is 5.6. And for the standard deviation, we could find the variance first. Variance will be np times 1 minus p. (14 times 0.4, 1 minus 0.4 is 0.6. Therefore, the standard deviation we can find is the square root of the variance, which is the square root of 3.36. We can keep 2 digits of decimal if we want to. 1 point is also okay. Right, 2 digits will be a little more accurate. So that we got the mean and standard deviation. Right, so cutting values. We can find this 2 standard deviation below the mean. That is 5.6 minus 2 times 1.83. Well, you can put that into a calculator and find 1.94, and 5.6 plus 2 times that's 9.26. So the usual range is within 1.96 to 9.26. Is between 1.94 and 2.96. Below 1.94 called unusual. Above 9.26 for the x value is called unusual as well. And below 1.96 is called unusually low. Above 9.26 is called unusually high. So 12 is unusually 12 is unusually high in this case. Alright, so that is everything of the binomial distribution, and so everything for the chapter 5 we had. And yeah, you will see more announcements on Blackboard. Then we'll go to our chapter 6. I will go to a new block of normal distribution. So that was everything for the chapter 5. Now we move on to chapter 6. Which we had first seen that was from the empirical rule. Right, the empirical rule say, well, within one standard deviation, that's 68% of data. Within two standard deviations, about 95% of the data. And so as the range rule of thumb saying within two standard deviation is usual, out of two standard deviations unusual because the middle two standard deviation covers 95% of the data. Out of that will be in the 5% of range, and the probability of unlikely is 5%, or it's less than 5%. Right, that was what it is. And that was our first time to see the normal distribution, and we had seen the z-score basically. Right, that was from the normal distribution anyway. And from this chapter, we'll see a lot of normal distribution. In the later chapter also, some conditions are about normal and something are approaching normal, and so on. Right, so that's what it is. And normal distribution is a so-called continuous probability distribution. Normal is a special type. It is a continuous probability distribution, as what we have seen before about the continuous probability distribution. Well, the continuous random variable has infinitely many values associated with measurement on a continuous scale or no gaps. That was the continuous random variable. Well, if you haven't seen that, that's also not very important. Well, it is a random variable whose distribution has a graph that is continuous, bell-shaped, and symmetric. Is said to follow a normal distribution. Of course, normal distribution is continuous, is bell-shaped, and is symmetric. Right, and the special thing, the notation, right? Random variable, it follows normal, has two parameters. Like the binomial n and p are the parameter. If we see binomial of n and p, we can do the problem, right? If we can see the normal distribution, we're given the mean and the variance, or in other words, the standard deviation. We can do the problem, right? The mean and the variance usually is input inside of the distribution, put inside the parenthesis, and also follows the Gaussian density. Well, this is the Gaussian density, and what it looks like. Is continuous, bell-shaped with the mean in the middle and symmetric. Bell-shaped, continuous, never stop from negative infinity to infinity, has the domain of the function, and it is exponential function, so the axis of symmetry, as of we can see the square here, axis of the symmetry will be the mean in the middle. Right, so the mean is where it stays, and the left side and right side have the same axis, same shape, same look like. Right, and how we calculate the probability is based on the density function. We'll see from a simple called the uniform distribution, we could extend to how we find the probability of the mean of the normal distribution. We'll see that later, but that is the density function. We had seen them a lot of times, right? The first time we see was the empirical rule, and the last time we have used the binomial distribution, even though it's discrete probability distribution, but it could be approximated by the normal distribution as well, follow some condition. Right, so even though binomial is discrete, but it could be do some correction, and it could be follow some condition or satisfy some condition, then could be approximated by the normal distribution. Right, but anyhow, the random variable has a mean and a variance. That is what it is, and the formula of density is called the Gaussian density. Right, is this one. E is the natural number you can find on calculator, about 2.718, and so on. Right, that is the distribution of the or the density of the distribution. Right, so normal distribution has two parameters, the mean and the variance. If we know these things, we know the Gaussian density already, then more likely we can find the probability of a certain range. Alright, the first standard deviation is its point of inflation, inflection point, which means it's changed the concavity from concave down to concave up of the graph. That is something involving in calculus, but that's within one standard deviation. And we have seen that majority, actually about 68% of the data is within that. Right? Out on the two-tail, that's about 32%. So categories or some properties. Right? The first one is x value taking value from negative infinity to positive infinity. The mean, median, and mode are equal and located at the center, which is the middle, where the highest density is our mean. We can see it's the highest density, which means the median is the middle, the mode is also there, the mean is also in the middle at the center. Right, that is the value of mean, median, and mode. The curve is symmetric by the mean, so if you know what it looks like on the left, it should be looking similarly. Just flip it, it will be same looking on the right side. It is a continuous curve, so it is no meaning to look at the probability of a point, but will be meaningful to looking at the probability of a certain range. Well, the curve never touches the x-axis, and for every probability distribution, the total probability will be 1. Especially the continuous probability distribution, the probability is the area under the curve. Right, for discrete probability, we have random variable corresponding to its probability. We get the total probability to be 1. For continuous random variable, the probability distribution of could given a density function, and the probability of a certain range, we have it here. The probability of this range within one standard deviation, we say is 68%. But the total from negative infinity to infinity, the area of it is 1. Right? The middle from one standard deviation below to one standard deviation above the mean, that is 68%, which means this range have an area is 0.68, the area. which the density shows only this value, the curve, y value of the curve, and the entire density, entire area is the probability. Area bounded by the values and bounded by the x-axis together with the density curve. Altogether we have area is the probability. Right, that's some reason why it is being called the density curve. The empirical rule applies in the normal distribution. But basically the empirical rule is from the normal distribution anyway. Of course it will apply. So to find the probability, that is the area under the curve. Right, so let's see something simpler. Instead of the normal distribution, we'll go introducing something else or something more basic, right, to see how we find the probability. Another distribution is called uniform. Distribution in the continuous version, right? In discrete probability distribution, it also has a uniform distribution. Uniform means the density is a horizontal line. Or uniform distribution means it's spread evenly on the interval a to b, but the density of the constant, the density is constant on this interval and zero elsewhere, which means on the interval we get the probability for a certain range and the zero out of that range of interval. The distribution of the density, since the entire area under the curve will be 1, therefore and also the range from a to b is b minus a, therefore the density will be 1 over b minus a. Right, for x value between a and b and 0 elsewhere. So that is this, right? Between A and B that have a height of the density to be 1 over b minus a, and out of range everything is 0. So that is the density function, and we can get the probability, right? The whole entire area under the curve, which is b minus a times 1 over b minus a, that is the area of 1. If we cut in one range, we are forming basically a rectangle. Then we're finding the area of the rectangle, that we can find the probability of this interval. Right, so let's see an example. Well, it says, well, distributed uniformly distributed between 100 and 102 minutes for the class, right? Therefore, f of x is between 100 and 102 minutes. That's 1 over 102 minus 100 is simply a half. It is a half for it to be 100 and 102. That's the density function. And asking for if the class is longer than 101.5 minutes, you will be late. What is the probability of late? Will be the probability of x is bigger than 101.5 minutes. Right, means 101.5 is here. That area is the likelihood of Kim will be late for the interview, right? Which is the area of the rectangle is base times height. The base is 0.5, height is 1/2. So the probability of her being late is 0.25. Of her to be on time is the unshaded part will be 75%. Right? Uniformly distributed, that is what it is. And if we extend it to normal distribution, if we want to find the probability of certain range, we'll do the same way to find the area under the curve. But there are a couple limitations of that method. Right? And we, of course, density is a line, here is a straight horizontal line, then we can find it by finding the area of rectangle. And for the normal distribution, since it's a Gaussian curve, right, it will be relatively a lot harder to find the integral, right, to find the area under the curve. So we will talk about that next time.